Hello guys, it's me, a Frost Knowledge Man. Today we're going to be talking about science. What is science? Science is the knowledge obtained by our five senses. We learn about nature by observing, testing, and then generating models that explain our observations. This knowledge, called science, helps us understand nature and its various aspects, and so it is extremely important. Chemistry is only one of the many principles of science. Chemistry is the knowledge of matter. It includes the study of the properties of matter, the identification of matter based on those properties, and the changes it undergoes. This brings us to the concept of matter. Matter is anything that has mass and occupies space. This means anything that we can touch or hold. Everything around us, from the food we eat, the air we breathe, the water we drink, the motor vehicles we ride, the medicines we take, our houses, all the way to the beautiful scenery in the world, the mountains, forests, lakes, rivers, oceans, plants, etc., are all made up of matter. So from this we can conclude that chemistry is directly related to our lives, and it has a hand in pretty much everything that we see in the world around us. In fact, many of the changes that we observe in the world around us are as a result of chemical reactions. For example, chemical reactions take place when leaves change color, when we cook, when we use cleaning detergents to wipe off our countertops, when foods rot, etc. The knowledge of chemistry has helped us develop petrochemical products. For example, medicines and drugs, papers and paints, papers and plastics, paints and pigments, insecticides and pesticides, etc. The list just keeps going on and on. Chemistry has also provided us the knowledge and techniques to maintain our health and keep ourselves healthy. But chemistry hasn't always brought us good. The development of the chemical industry also generated toxic wastes, it contaminated the water, and polluted the air around us. So chemistry hasn't always bring us good. It also brings a lot of bad. Next, we have chemistry in action. Chemistry looks at materials macroscopically and microscopically. Macroscopically means looking at a material the way it appears, measured and touched, while microscopically means looking at a material and imagining or looking at it as if it is made up of hundreds of thousands of millions of billions of tiny particles, meaning looking at a material at particle level. For example, ordinary people would think that the rotting of an apple is a physical change as it changes its color. But if you ask a chemist the same exact question, he would actually explain it as a chemical reaction between the atoms of iron in the apple and the atoms of oxygen in the air surrounding the apple. And that caused the apple to rust, or actually the iron in the apple to rust, and that caused a change of color. That's how he would explain it. Next, we have chemistry and the environment. The knowledge of chemistry is necessary if we want to understand and learn the effects of chemicals on the environment. For example, with the knowledge of chemistry, we can identify the best materials as nutrients for our plants to help them grow faster. Or we can identify ways to get rid of chemicals without polluting the air or water supply, etc. There are much more uses of knowledge of chemistry in the environment. Next, we have chemistry and other sciences. Chemistry concepts are extremely important in other disciplines. It is key to cooking, physics, biology, astronomy. And chemistry is fun. Chemistry can be used to change colors, alter recipes, make stuff glow in the dark, and even make stuff explode. Chemistry has been divided into some main principles. They are physical chemistry, organic chemistry, inorganic chemistry, biochemistry, industrial chemistry, nuclear chemistry, environmental chemistry, and analytical chemistry. Starting off with physical chemistry. Physical chemistry is the branch of chemistry that deals with the composition and physical properties of matter and the changes they undergo. Next we have organic chemistry. Organic chemistry is the branch of chemistry that deals with the study of the covalent compounds of carbon and hydrogen, in other words, hydrocarbons, and their derivatives. Organic compounds occur naturally, and they're also synthesized in labs, meaning some chemists make them in labs. And organic chemists determine the composition and physical properties of both naturally occurring and synthesized in lab compounds. Next up we have inorganic chemistry. Inorganic chemistry studies all the elements and their compounds, excluding hydrocarbons and their derivatives. The use of this branch is seen in every aspect of the chemical industry, like glass, cement, ceramics, metallurgy, etc., etc. Next, we have biochemistry. Biochemistry is the branch of chemistry that deals with the study of the structure, composition, and chemical reactions of substances found in living organisms. It covers all the chemical reactions that take place in living organisms, such as synthesis and metabolism of biomolecules like carbohydrates, proteins, and fats. Biochemistry emerged as a separate discipline when scientists were studying how living things got energy from food, and how fundamental biological changes occurred during a disease. Examples of the use of or the application of biochemistry are seen in the fields of medicine, food science, and agriculture, etc., etc. Next, we have industrial chemistry. Industrial chemistry is the branch of chemistry that deals with the manufacturing of chemical compounds at the commercial scale. It deals with the manufacturing of basic chemicals like oxygen, chlorine, ammonia, caustic soda, nitric acid, and sulfuric acid, etc., etc. These basic chemicals, serve as raw materials in many other industries like fertilizers, soaps, textiles, agricultural products, papers, etc., etc. Next, we have nuclear chemistry. Nuclear chemistry is the branch of chemistry that deals with the radioactivity, nuclear processes, and properties. The main concern of this branch is the atomic energy and its daily uses, or its uses in daily life. Same thing. It also involves the study of the chemical effects resulting from the absorption of radiation within animals, plants, and other materials. This branch has application in medical treatment, radiotherapy, preservation of food, and the generation of electrical power through nuclear reactors, etc., etc. Next up, we have environmental chemistry. Environmental chemistry is the branch of chemistry that studies the components of the environment and the effects of human activities on the environment. And the knowledge of the chemical processes that take place in the environment is very important for its improvement, and protection against pollution. Lastly, we have analytical chemistry. Analytical chemistry is the branch of chemistry that deals with the separation and analysis of a sample of matter to identify its components. The separation is carried out prior to qualitative and quantitative analysis. Qualitative analysis determines the identity of a substance, meaning the composition of chemical species, while quantitative analysis determines the amount of components of each substance present in the sample. And the different techniques and instruments that are used for analysis are studied under this branch, and the scope of this branch covers food, water, environmental, and clinical analysis. That's it for today's video, guys. Hope you guys enjoyed and understood all the branches and everything else. If you guys have any confusions or any questions, feel free to shoot me a message in the comment section and we'll spend more time on it. Peace out.